Hello, my name is Jack Stahl, and this is Team 3's Design Phase 2 presentation for the AquaPaws automatic water dispenser for pets. Our foundational topics shown here, we have our mission statement, we have our customer needs, and we have our customer profile here. So the mission statement, it outlines our project. It shows our primary market here as college students that are pet owners, secondary as frequent travelers, not as important to us, but still important. We have material costs here shown, trying to have it under $80 to make it more affordable for the average college student, average person. Our customer profile here, we have an average college student that has a pet and is busy during the day on campus, doesn't have enough time to go back and tend to his pet. Then we have here our customer needs. We have more basic stuff like battery power, aesthetics, and then we also have the important one for us here was the product has a sensor that alerts the user when it needs to be refilled. Here we have our functional decomposition. So our mission here at the top, providing pets a reliable, autonomous access to water that uses a low cost and college student friendly solution. So here in the middle, we have our product, and then we have the inputs and the outputs here. So at the top, we have our energy, and then the material, and then the signal down here. So first we have the energy coming in, we have the battery power coming in, and then out is the water dispensed through the faucet. And we have the water, the material being the water in the tank, and then the material out being the water into the bowl. And then we have our water level sensor as the signal, which then comes out and signals the user a refill alert when the overall tank needs to be filled up. So we use these and we broke them down into 5 sub-functions. So our first was the sensor detects a low water level in the water bowl, and then the Arduino, it interprets this signal and then it turns on the DC motor. Then the battery powers that DC motor, and the water is dispensed from the faucet and from the tank through the faucet into the water bowl. Then the system resets and it starts over again with a new cycle. Here we have our concept generation table. This helped us set an outline for our design. It guided our team brainstorming for our product, and it clarified our design priorities based on our customer needs. So we have down here our weight of importance, comments, customer needs. So we have our highest weight of importance was the power supply. We tried out a couple different power supplies, but we determined that the 9-volt battery made the most sense for us. It's easier to replace every so often, and it's easier than a wall outlet because you can move the product around anywhere that makes sense for the home. Our second most important here was the attention to the product. This was at a medium level because it doesn't always need attention. It could have daily checks to refill water depending on the size of the product. Also, cleanliness, probably weekly or so. So it's not as important as the power level here. And then we have our size of the design, which was our lowest weight of importance customer need. A smaller tank could be easier to move around, but then it would take more refilling. So this was not the most important one to us. So this also helped us set the criteria for our screening and scoring, which we will see later. Another concept generation tactic we used here was the 6-3-5-3-2-1 method. So this helped us narrow down which general concept we wanted to use. It solidified in the end, our final general concept we based off of this. It also encouraged our group to all participate and build off of each other's drawings. It was an efficient way to produce a high volume of solutions in a short amount of time, and it balanced our creativity and feasibility. So at the top here, we have our original concept that we worked off of with a bowl around the tank. more of a circular option here in all of these. And then we work down to the one in the bottom left, which I would say is the most similar to our final product. And we have the microcontroller with the battery power, the sensor, and the larger water tank there. So yeah, we'll move on to our gallery method here, which you can see we built off of our previous solutions, made them a little more detailed from the 635 method. We have our sub-functions listed down here. We have the power source, we have our motors, and we have our water dispenser methods. So each of us drew 2 designs here using these different combinations of sub-functions. It clarified which sub-functions had a higher strength and which sub-functions we could eliminate. We also got that from our feedback, which was mostly positive, but it helped us eliminate stuff like the waterfall and the solar panel, which would make more sense for a build-off if we were doing an outside water tank for a pet. Then we have our concept screening here, which we built off of from earlier generation. So we have our potential solutions, there are 6 solutions here that were seen in the gallery method poster. And then we have our criteria here. So we have the dispenser, the size, the water capacity, the ability to assemble the product easily, the battery power. We have compatibility with water filters for cleaning, and the aesthetic to build a nice aesthetic for your college dorm. So we have a method here. We summed up the positives and we summed up the zeros and the minus. And we got a net score for each of our 6 concepts here. And we ended up ranking concept A as our primary target here, with the other ones having a negative outlook. We had this one being the best one for us. So based off that screening, we took our concept A and we put it into a CAD model, each of us building a sub part of this here product. So we have over here on the left our base faucet there with a ball valve there on top to switch it on and off. And then we have our entire solution here. You can see our water tank right here with a lid, and then we have our water bowl here and the faucet there, you can see that. And then what you can't see inside of this larger tank at the bottom, we have a compartment, and then you can see the little sub-compartments for the battery and the Arduino servo there. So all of this works together to be our final concept solution. Thank you for your time.